Hello everyone, in this video we are going to see about the line clipping algorithm, which is given by the Cohen-Sutherland. Line clipping is the process of removing lines or portions of the lines outside an area of interest, a viewport or a volume. Viewport is in the two-dimensional case and view volume is in the three-dimensional case. There are two common algorithms, Cohen-Sutherland and Lian-Baske. This video we are going to discuss about the Cohen-Sutherland algorithm. Works is it first detects the line lies inside the screen or outside the screen. That means the line should be visible or not visible. So you have three cases here. All the lines come under any of the three cases. One is visible, next is not visible, and third one is clipping case. That means partially visible. Okay. So now visible means if a line lies within the window, that means both the end points. We know that line have two end points. If both the end points lie within the window, now the line is totally visible. Okay. So that line will be displayed. Next case is not visible. If a line lies outside the window, it will be invisible. So that means outside means it may be totally to the left of the window, right of the window, top or the bottom of the window. Such lines will not be displayed. They will be rejected. So if any of the following inequalities is satisfied, then the line is considered invisible. Means we are checking the line points x and y with the left and the right boundary, which is the x min, y min, x min, x max, and the top and the bottom with the y min, y max. So that means all the minimum x and minimum of x and y, likewise maximum of x and y against the top, bottom, left and right window area. So that means it become not visible. The third case is the clipping case. If the line is neither visible nor invisible, that means it is considered as the clipped case. So what is the clipping case? How to do this? First of all, the category of a line is found based on the 9 regions given in the next slide. So we are dividing this, the area into 9 regions. So each region has its own meaning. So the first we have to check whether the line is found in which of the 9 regions. All the 9 regions are given some codes, and each code is of 4 bits. And if both the end points of the line have end bits 0, then the line is considered to be visible. Okay, let us see with an example in the next slide. This is a region code. The center area is having the code 0000. That means it's totally visible. It is inside the window. For example, here we can see the region 5 is given the code. The region 5 is the totally visible area 000. And the other, for example, region 3 is given 1010, region 6 is given 0010. Likewise, we are assigning the values to the bit codes. Let us see how to assign the codes. You can see this this picture diagram where we have the codes as actually the values will be from 0 to 8, because you are having 0 to 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 regions are there, and we'll have the 9 different combinations of the bits. Okay, let us see how the bits are assigned. So initially, first let's go for 0, 0, 0, 0, 0. That means all are 0. The area is not right, not left, not top, and not bottom. Everything is inside. So it is given as 0, 0, 0. Okay. Now see to the left of the window where all the values of the LSB on the right, it is the first bit, which is the 111. So here we can see that to the window of the left we have the first bit LSB as 111, which means the left bit are the codes are assigned as first bit is 2 power 0, that is the first LSB is given the left position, and the second is right, and the third bit stands for bottom, and the fourth bit stands for top. Okay, so if the code is to the left means all the LSB will be 111. We can see here. Okay, so put 111 in the LSB position, and then others are 0. Remaining other 6 regions, the value will be 0. So put the ones digit as 000 in all the other areas. Okay, now the second bit, all the a regions which is in the right, which is region 3, 6 and a 9. They are to the right of the window. So there the second bit will be 1. You can see here 1, 1, 1, 1. Okay. So in the case of region 3, 6 and 9, it is not to the left. So all the LSB are 0. Now it is to the right. So the values are 1, 1, 1 in the second position next to the LSB. Okay. Now consider the region 2 and 8 for example. Okay. So now the 2 is the region which is top and 8 is in the bottom. Okay. Now you can see in the top portion, in the region 2, the code is 1000. That means LSB is 0, it is not to the left. Next position is 0, it is not to the right. Third is for bottom, so that is also 0. Now only the fourth bit is 1, which is the top bit. Okay, so 100 means it is totally to the top. Likewise, see the region 8. In the region 8, the value is 0100. That means it is not left, it is not right, it is in the bottom. So the third bit is for bottom, fourth bit is 0, which is not the top. Okay. So likewise, we have to assign the codes of each of the region by checking whether the code is left, right, top or bottom. Now see the special case. In the case of the region 1. Okay, in region 1, the value is 1001. That means region 1 is, it is on the top, also on the left. That means what? Top bit is the fourth bit, put 1. And then this left bit is LSB, that also put 1. Remaining are 0. Okay. So likewise, you have to assign the codes for the region. Now the codes are assigned. Then we have to check for the algorithm. So what the algorithm says is, compute the codes for the two end points. So we have to check whether the end point is in the all of one of the 9 regions. One of the 9 regions you have to check and you have to assign the codes. And we have to start the loop to display or to discard all the lines of the scene. So we have to enter in the loop and check if both the region codes are 0. That means if both the end are 0 means the line is totally inside the window. So move it to the display file to display and exit. Okay. And if both the region codes are not 0, that means it has some, it may be into the left, in the left end, it may be started, it will be end in the right end, it may go to the top. That means when it is there other than center means it has some non-zero codes. Okay, so that non-zero codes are logically AND together. When we are AND together, we have to check the result. We know that A and B is equal to 0 when any of the value is 0. Okay, so if the answer is totally non-zero means the lines are totally somewhere to the left or totally right or totally top or totally bottom. That is the meaning of the answer is non-zero means. So that is also totally rejected. Okay. So two cases we have seen. First case is totally inside. Second case is totally outside. Now the next point says, if the result is 0, then subdivide the line from intersection point of the line and clipping boundary and repeat step 2, 3 and 4. So what you have to do? Now we have to check for the cases where the line sometimes started with the left edge, ending in the right edge, sometimes started from the top, ending in the right. All the possibilities are there. Okay. So we have to check when they start from left and end in the right, it will surely cross the window. So we have to check out which area it is intersecting with the window. That is the intersection point of the line by the boundary. Then we have to save the intersection point, and that is the special case when we have to save the part of the line. Some line might have crossed the left and got inside and not to the right. Some line may have crossed both the boundaries. So it depends upon the line they draw. So accordingly we have to reject we have to save the line partially, the remaining lines which is clipped. Okay. Special case is that when the test 4 fails. So there are some cases where the test 4 fails means the lines cannot be considered in any cases. So that is the special case. Okay, so considering these cases, we see the example here. Here the line AB is totally inside, it is visible, and the line OP is an invisible case, it is totally on the top of the window, so it is discarded. And then line P comma Q is an invisible line, it is totally to the left of the window, sorry, to the right of the window. And then line IJ are the invisible line which is totally in the left side of the window. And then we have the lines M and N, which is the clipping candidate. So what is the clipping candidate? Here again C and D is also the clipping candidate, means the line C starts inside the window and end in the right side. Okay, likewise M starts in the inside window and ends in the bottom right. Okay, so two different cases. So seeing the lines, I hope you are able to easily analyze how the lines are will be clipped. And now how the answer will be here. OP will be totally not in the answer. OP, PQ, IJ all will be clipped totally. And AB will be fully inside. Now CD crossing the right window. So it will be intersected at the window boundary. A new point will be saved. Then that will be CD dash. Likewise, in the case of this line MN, it's again a case where it is crossing with the top, though it is ending in the left. Okay, it is just ending in the bottom right. It is crossing the window in the bottom side. So the intersection of the line MN with the bottom window is found out, and the new point will be MN dash. So this is the remaining part of the line which has been clipped. So that's all the process. Let us see the algorithm now. So now the algorithm is going to define left edge, right edge, bottom edge and top edge. Okay, before that we have another definition here. Define round of A is equal to int of A plus 0.5. Here often we have some process to round off. So normally how we round off 3.5 means 4, 3.8 means 4. So we will add some 0.5 and round off the value. That is our common used in this program. So we are just using a function, we are defining a function round of A. Next the part we are defining 4 constants: left edge, right edge, bottom edge and top edge. So we can see here, as I told in the previous explanation, 0x is all about the hexadecimal values. So 1, 2, 4, 8 values. In the case of binary 1, the answer will be 0, 0, 0, 1. That means LSB will be 1, which is the left side indicator, and 0 cross 2, which is the right, because the answer is the binary value is 0, 0, 1, 0. Second is bit for is right, and for the value 4, the binary is 0, 1, 0, 0. So the third bit will be 1. There it is for the bottom, and the top is the fourth bit. Now there is given the value 0 cross 8. 8 has the binary value 1, 0, 0, 0. That means the first, the MSB is the having the value 1, others are 0. So now this is the definition for why we defining the value 0, 1, 2, 4 and 8 for the left, right, bottom and top edges. Okay. Next section is all about defining some small functions we are going to use here. So inside of A is one function to check whether the point is inside the boundary. Next, reject of A comma B is another function which is going to check whether the line is going to be totally rejected. So the two endpoints A and B are here. So the function definition is A and B. You have to logically AND the endpoints A and B. Okay. In the case of inside, only one point is given because both the endpoints are 0. So same point. So it is only given as A. Okay. So the definition is not of A means it is going to be inside the window. It's true. Next, reject 2 points. At the end we are going to AND, logically AND the two endpoints. That is reject function. Third is the accept point. Accept function, the definition is not of A or B. So we find the logical OR of two endpoints A and B, and then there we take the not function, the complement of this value, to accept the lines. Okay, so definitions are over. So initially we have defined one function round, then we have defined 4 constants left, right, bottom and top. Then we have 3 different functions inside, reject and accept, whether to accept totally the line or reject the line or partially intersect the line. Okay. So the constants are over. Next we are going to encode the lines. Why should we encode? Because we are going to find the logical operation and or to confirm the line is visible or invisible. For that we have to encode all the lines. So to encode all the lines, we should give the endpoints of both the lines, of all the lines. So point 1 and point 2. So the parameter is world is WCPT2 means world coordinate point in format. We are giving point 1, and then in the device coordinate point we are giving win-min and win-max. Okay, because we are going to encode the point x comma y under the with respect to the window win-min and win-max. Okay, that may be x and y. That is also both x and y, but it is commonly called win-min and win-max. Okay, yes. Now we are assigning a simple value for initially the code is given as 0, and then we are checked whether the point x is lying within the left. Okay, so x less than win-min dot x. That means code is equal to code or left edge. That means the point is in the points in the left side, so we are taking as a left edge. Next what you are doing, if point dot x is greater than win max x means it is in the right side. Okay, the value is x is greater means it is in the right side of the window. So the code is given as code is equal to code or right edge. Likewise, point y less than win min means it is in the bottom. Then we are giving the code as code is equal to code pipeline bottom edge. Likewise, win max y means top. So which is we are checking with the point y is greater than the win max, that means the top edge. Okay, so for all the cases left, right, bottom and top, we are assigning the code based upon whether the point lies in the minimum or the maximum of the window left and right, top and bottom. So the encoding is over. Now the next part of the program is we have to swap the points. Why to swap the points? If the points are to be interchanged, as we see in the case when they cross each other, the boundary, we have to interchange the points. Okay, accordingly we have to interchange the code also. So we are using the void swap points is the function name. What we are going to swap point 1 and point 2. So it comes under WC point. So they given as a pointer variable star asterisk p1 and asterisk p2. They are the two parameters to exchange. So how to exchange? As usual, we do the exchange with the temporary variable. WCPT2 is in the form, it is TMP is the intermediate variable, and now we are assigning temp is equal to star P1, then P1 is equal to P2, then P2 is equal to temp. This is a normal swapping code to exchange the two value of the two variables. And accordingly, we have to swap the code also. So the next function says about the swap codes. What we are going to swap? Code 1 and code 2. So C1 and C2. So the same thing here. Declare the temporary variable to use in between exchanging. So unsigned char TMP. Then we have to put TMP the C1 value. Now Cn can hold some other value. So C1 is equal to C2. Now C2 is assumed to be empty. So it will hold the temporary value. That means the two values, the two codes of the end point, the intersection points are interchanged. Okay. So this next we have the real function which is going to find the whether to check whether the line is inside, outside or partially crossing. So the function says void clip line. DC means device coordinate point win min win max, then world coordinate point P1 P2. These are the 4 points to consider as an argument for the clip line function. So here we define the unsigned character code 1 and code 2. Integer done is equal to false, draw is equal to false means initially nothing is done, nothing is drawn. Just we are going to start, like how you give the variables value A0, B0, likewise you are giving is a boolean value, done is false and draw is also false. If we have a float m, which is the slope of the line, we find in the later part of the program y2 minus y1 by x2 minus x1. For that we need the floating variable m. Okay, so now the program, the while loop starts. So it is checking while done, while not done. That means we have to do more. That means since lines are there to check it is inside, outside, or crossing, we are using the loop as while not of done. Not of done, what you have to do first, you have to encode. Okay, we have to find the code. So that is done by the function encode of p1 comma winmin max, winmin and winmax. Likewise, we have code the next line also, next end of the line also, p2 comma winmin and winmax. So the two lines are encoded. That means I given the code to the end points, code 1 and code 2. Now we check if it is acceptable. If accept of code 1 comma code 2 means this accept is function is called to check whether the code 1 and code 2 are inside. That means it is true. So done is equal to true and draw is equal to true. We have to accept the line. So we have to consider as a true case and to draw the line inside the display window. Else we may reject. So how to reject? We call the function reject of code 1 comma code 2. What the function does is it does the AND operation between the end points and give the not of A and B. So accordingly the answer is accordingly we are checking it is done is equal to true, and that means we are going to reject the line. Else we are checking whether the line is crossing, so it is inside. Okay, so inside the code 1, if it is inside means yes, you have to accept. Okay, so we are going to accept the line, so that is done by before that we have to swap the code, swap the points. Okay, so after we are done swap the points and swap the codes, the third case is over. Now we are going to find out the next case. Yes, now to continue with the next case, we need the mathematical equation for left, right, top and bottom. Based on this only we are going to use this equation. Okay, use this equation to find out the line is crossing which area. Okay, so for that we have the mathematical equation. Just have a look on that. Y is equal to mx plus y1. That is the okay. Now y is equal to mx plus y1, x here xl minus x1 because it is in the left. Likewise in the next case right xr minus x1. Okay, in the right side the point will be there. Likewise y top and y bottom. So we are just instead of there's y2 minus y1, we are putting yt minus y1 like yb minus y1 because that is the top and the bottom values. Okay, so by this is the formula to find out the intersection. So y is equal to m xl minus x1 plus y1. In the case of left and right, the m is assumed is the m is not equal to infinity. Likewise for top and bottom, the thing is that m is not equal to 0. It has some slope. Okay, so now based on that we have this equation to continue. So if p2 dot x not equal to p1 dot x means if both the endpoints, if they are not same means they are different. Okay, so if both the points are different only we can have a line. Okay, so that is what done over here. So that is, if that is the case, we have to check for the m is equal to find the slope y2 minus y1 by x2 minus x1. That is done by p2 dot y minus p1 dot y, p2 dot x minus p1 dot x, y2 minus y1 by x2 minus x1. Slope is found out. Then we are checking whether if the code and left edge, that means if the point lies in the left edge means we have to find the point as the new point as p1 dot y is equal to p1 dot y plus winmin x minus p1 x dot m. This is what just we checked in the previous slide. We are setting the y and the x value. So x is just winmin x, but for the case of y we have to apply the formula to get the left side edge. Okay, else the same code is written with the right edge, and that means we are having the win max, all dealing with the win max. Okay, else we are working with the bottom. So bottom we have the point is if p2 dot x not equal to p2 dot 1. The same way here also, if they are not equal means they are different points, then only we can draw the line. Okay, so now the same is repeated for the bottom and the top. So p1 dot x is equal to p1 dot x plus winmin dot y and minus p1 dot y. So here we all deal with the y points for the top and the bottom case. Same thing is repeated here. Okay. Yes, now we have checked, we have just found out the cross section of these points with the left, top, bottom and right edges. So now we have saved the points. Now after saving the points, we have to draw the line. Okay, so we have to check if draw. First we have put if draw. First of all, we have given draw is equal to none. Now we are checking if draw. That means if it is, we have to draw is equal to 2 means if you are going to draw means if it is draw, then call the algorithm line DDA round p1 dot x, round p1 dot y, round p2 dot x, round p2 dot y. Now all these points we have found out in the previous code p1, p2 with the values x and y, and we are rounding off all the values using the first function we had defined in the starting of the program. So the line is drawn. Okay, that's all. This is the long algorithm that deals with the, first of all, with the checking whether they are lie on the region, then coding the values, then we have interchanging and exchanging based upon the availability of the line in the left, right or top and bottom window, and finally we call the DDA algorithm to draw the remaining lines which is to be displayed on the screen. Hope it is clear to follow, and thanks for watching.